Good morning, Algebra 2. This is Benchmark Week. Benchmark is opened on Monday, March the 11th, and it will go through March the 15th. Make sure that your test is completed by Friday, March the 15th. The benchmark counts as a grade in quarter 4. All right, we're going to be looking at in lesson 4.02 what is called arithmetic sequences. And we're going to go over some definitions here for arithmetic sequences. An arithmetic sequence is an ordered list of numbers called terms. That sequence can be finite or infinite. A sequence that looks like this, 1, 3, 5, 7, is a finite sequence because it ends. It has a specific number of terms. It has 4 terms. A sequence that is infinite means that you have a sequence that is going forever and ever and ever. And to show that it is an infinite sequence, where you're going to put a ... at the end, which means that it keeps going. So if you see a sequence with just numbers listed, that is finite. If you see a ... at the end, it is infinite. In this section, we are going to be talking about 2 types of formulas. We're going to be looking at the explicit formula for an arithmetic sequence and recursive formula. The explicit formula is an equation. And because it is an equation, it is going to look like this. A sub n is equal to some expression. It defines the sequence, and it can be used to find the terms. So with an explicit formula, we are going to use it to find a specific term. A recursive formula is also going to be an equation, and it is also going to start with a sub n, and it is going to use the term before. And when we go over examples, this will make a lot of sense. Arithmetic sequence is a sequence that uses addition or subtraction to go between terms, known as the common difference. To find the common difference, we always want to use the following method. We want to take the second term, and we want to subtract the first term. And when we do that, that will give us our common difference, which is D. Okay, this is the explicit formula for an arithmetic sequence, and when you look at that, you're thinking, I'm sure, oh my gosh, am I going to have to memorize this formula? The answer to that is no. The formula can be found on the SOL formula sheet, and we are going to find that by looking for the Algebra 2 SOL formula sheet. That formula sheet can be used on all quizzes, on all tests, anything that we're doing. It can also be used on the SOL test. You are going to be given that formula sheet. I will post the formula sheet in the content. Therefore, you will have it at your access. Okay, the explicit formula for an arithmetic sequence is a sub n is equal to a sub 1 plus n minus 1 times d. We are going to define the parts of this formula that are important. A sub 1 is going to be the first term. N is going to be the number of terms, or we might think of it as being the term number. And D, we know, is that common difference. And to get that common difference, we know that we are always going to do the second term minus the first term. And that will give us the value for D. Okay, the recursive formula for an arithmetic sequence is A sub n is equal to A sub n minus 1 plus D. On this, you are going to be using the previous term to find the next term. So in our definitions of each part of this, A sub n minus 1 is going to be the previous term. N is going to be the term number. And that means if you have A sub 5, we're finding the fifth term. Okay, if you are given A sub 2, that means we're finding the second term. So that N is just the term number. D is your common difference. And your common difference, again, is found by taking the second term minus the first term. All right, in this example, it says, what is the fourth term of the recursive sequence when you are given A sub 1 is equal to 2, and the formula is A sub n equal 3 times A sub n minus 1 minus 1. All right, we know in a recursive sequence that we have to use the previous term. So the term that I am looking for is the fourth term. So I'm finding A sub 4. In order to find A sub 4 using the recursive formula, I must know A sub 3, and I do not. In order to know A sub 3, I must know A sub 2, and I do not. In order to find A sub 2, I must know A sub 1, and I do. A sub 1 is equal to 2. So to find the values, to find A sub 2, I'm going to plug that into the formula. The formula is A sub n is equal to 3 times the previous term, which is 2, minus 1, which gives me 5. To find A sub 3, I'm going to plug into the formula 3 times the previous term, which is 5, minus 1, and that is 14. To find A sub 4, I'm going to be using the previous term, A sub 3, so it is going to be 3 times the previous term minus 1, which is equal to 41. So using a recursive formula, we find that the fourth term is 41. Which sequence is not arithmetic? To prove that it is not arithmetic, I have to find the common difference for each problem. The difference on answer A, I'm going to take the second term, and I'm going to subtract the first term, and that's going to give me 7 minus 4 is 3. So I'm going to check to see if this is arithmetic by adding 3 to each term. 4 plus 3 is equal to 7. 7 plus 3 is equal to 10. 10 plus 3 is equal to 13. 13 plus 3 is 16. Therefore, A is arithmetic. And I'm going to do the same thing on each part. On B, I'm going to take the second term, and I'm going to subtract the first term, and I get a difference of -4. I'm going to check. If I subtract 4 from 1, I get -3. -3 minus 4 is -7. -7 minus 4 is -11. Therefore, B is arithmetic. All right, I'm going to try C. Second term is 4, minus the first term is 2, and I get D is equal to 2. If I add 2 to 2, I get 4. But if I add 4 plus 2, it does not equal 8. So C would be the correct answer. On D, I'm sure when we're looking at D, we're thinking, oh my gosh, this is awful. It's fractions. But remember, you have Desmos. So you're going to find the difference, 5/6 minus 1/2. And when you do that on Desmos, it's going to give you a decimal. But when you simplify that back to a fraction, you're going to end up with 1/3. And you're going to add 1/3 to each of these and check that on Desmos, and it does work. So D is arithmetic. Don't let D be any harder than the rest just because it has fractions. All right, this question asks for us to write the explicit formula for the sequence -3, -1, 1, 3, and 5. In order to do this, we have to know what the explicit formula is. It is A sub n is equal to A sub 1 plus n minus 1 times D. N minus 1 times D. In order to write this formula, I have to know two things. I have to know what A sub 1 is, and I can tell by looking at the problem that the first term in the sequence is -3, and I have to know what D is. And to find D, remember it is always that second term minus the first term, and when I simplify that, I get a common difference of 2. Therefore, now I'm going to plug those two values into my formula. I have A sub n is equal to A sub 1, which is -3, plus n minus 1 times 2. Now, in order to have a final answer, I have to simplify this equation. On the right-hand side, I have n minus 1 times 2. That is distributive property. Normally, we see it with the number in front of the parentheses. But even if it is behind, it simply means that we are multiplying everything inside by 2. So that's going to be my next step. 2 times n is 2n, and 2 times 1 is 2. At this point, I have like terms that I can combine together, and I would have my explicit formula is A sub n equals 2n minus 5. All right, this is asking for the 14th term of the sequence with a first term of 7. So I know A sub 1 is 7. It has a common difference of 10. So D is equal to 10. And I'm looking for the 14th term. So N is 14. When I'm given those three pieces of information, I'm going to be using the explicit formula. And the explicit formula, again, is A sub n is equal to a sub 1 plus n minus 1 times d. And I'm going to plug in. N is 14, so a sub 14 represents the 14th term, equals a sub 1, which was 7, plus n is 14, times d, which is 10. I'm going to type this into Desmos, and when I do that, I'm going to find that a sub 14 is 137, which is answer B. All right, on this example, we are asked to find the first term of the arithmetic sequence with a term 3 of 10 and a term 6 of 28. So I'm just going to do some blanks here. The first blank is going to represent a sub 1. Second blank, a sub 2. Third blank, we know it is 10, and that is a sub 3. We don't know a sub 4. We don't know a sub 5. And we do know a sub 6, which is 28. Right, so in order to find this first term, it is very important that I be able to determine what D is. Okay, D we normally do a sub 2 minus a sub 1, but we don't know that. We don't have two terms that are directly together. But I do know that to get a sub 4, I would add D to 10. To get a sub 5, I would add D to a sub 4. And to get a sub 6, I would add D to a sub 5. So I'm adding D 3 times. To find my difference, I'm going to find the difference between the two terms that are given. 28 minus 10 is 18. And because I'm adding D 3 times, I have to divide this distance, this difference, by 3. So that means if I was doing this sequence, I would add 6 to 10, and it would give me 16. I would add 6 to 16, and the fifth term would be 22. And I would add 6 to 22, and it would give me the sixth term, 28. That is going forward. If we went backwards, we are not going to be adding 6. We are going to be subtracting that difference. So, in order to find a sub 2, I'm going to subtract D from 10. So this would give me 10 minus 6, which is 4. And to get a sub 1, I'm going to take 4 minus 6, which would give me negative 2. This problem is a little bit different because you have that gap between the values, but because you're adding D 3 times, you would just divide by 3 to get that difference. All right, we are told in this problem that a sub 1 is 8, and we want to find the third term. To find the third term of a recursive sequence, we have to know what a sub 2 is. And to find a sub 2, I'm going to replace into my recursive formula negative 2 times the previous number plus 5. And when I do that, I'm going to end up with negative 11. To get a sub 3, I'm going to plug into my recursive formula negative 2 times the previous term, which was negative 11, plus 5, and that is equal to 27. So correct answer would be answer B. All right, another example of recursive formula, and it is asking for us to find the fifth term. So in order to find the fifth term, we have to know what the fourth term is. In order to find the fourth, we have to know the third. In order to find the third, we have to know the second. So in order to do this, I'm going to have to find the second term, the third term, and the fourth term in order to be able to find that fifth term. So to do that, to find a sub 2, I know a sub 2 is, according to my formula, is going to be 6 times the previous term, which is a sub 1, plus 2. And that's going to give me an answer of 32. All right, now I'm able to find the third term because I know the second term. And I'm going to plug into my formula 6 times the second term plus 2. And when I do that, I get 194. And I'm just typing these expressions into Desmos. The fourth term is going to be 6 times the third term plus 2. And when I multiply that out, I get 1,166 as my answer. To get the fifth term, it's going to be 6 times the previous term, which is the fourth term, plus 2. And when I do that, I'm going to end up with 6,998, which is my final answer. All right, on the last example, it asked for the recursive formula for the sequence 4, 1, -2, and -5. And remember, that ... at the end means that it keeps on going forever and ever. It is infinite. In order to write this formula, all we have to know is the value of D. And to find D, again, we're going to take the second term minus the first term. And in this case, it is going to be 1 minus 4, which has a value of -3. Therefore, my recursive formula is A sub n is equal to A sub n minus 1 minus 3. Again, I am going to post the formula sheet for Algebra 2 that can be used on tests, on quizzes, on the SOL test. That way you will know what your explicit formula is and what your recursive formula is.